Good morning. This is Dr. Davamani. I'm an assistant professor, Department of Computer Science, Shift 2. Today, I'm going to present the topic on data link control and protocols in the course name Computer Network. So, let's see about the data link control and the protocols which are used here. So, the most important responsibilities of the data link layer are flow control and error control. So we are going to see how the data transmission flow which has been controlled by the data link layer and the error correction and reduction. In general, we can say it is an error control mechanism by the data link layer. So let's see one by one. So flow control. So what does mean by flow control? Flow control, which refers to a set of procedures which are used to restrict the amount of data that the sender can send before waiting for the acknowledgement. That means before receiving an acknowledgement, how many data frames that can be transmitted, that can be controlled. That is called flow control. So here that means data must be checked and processed before they can be used. I mean the rate of such processing, the data must be checked and processing, which takes larger time than the rate of transmission. So transmission time is very less when compared with the data processing. For this reason, each receiver has a buffer to store the incoming data until they are processed. If the buffer begins to fill up, the sender must slow or halt the transmission for some time. Then error control. It is both error detection and correction. Error correction in the data link layer, which can be implemented very simply, because anytime an error is detected in exchange of data or the transmission, that specified frames are retransmitted. So this process is called automatic repeat request. Error control in the data link layer is based on automatic repeat request protocol, which is the retransmission of data. So if there is any error occurs, then the sent frames which can be retransmitted automatically. So for that, what are all the protocols which we can use? Let's see here. So the data link layer can combine the flow control and error control to achieve the delivery of data frames successfully from one node to the another node. So the protocols are normally implemented in software by using any one of the common programming languages. So some of the protocols which can be implemented in the languages are stop and wait ARQ, go back N ARQ, and selective repeat ARQ. So today let's see the stop and wait ARQ protocols. It is the simplest flow and error control mechanism. A transmitter which sends a frame then stops and waits for an acknowledgement. The stop and wait ARQ has the following features. So now let's see how the stop and wait ARQ protocol which works, which is very simplest flow and error control mechanism. A transmitter here sends a frame and then stops and waits for some time in order to receive an acknowledgement. So stop and wait ARQ, which has the following features. So let's see the features which will be helpful in order to ensure that the receiver has received the frame successfully or not. The sending device keeps a copy of the sent frame which has been transmitted until it receives an acknowledgement. If the sender starts a timer when it sends a frame. If an acknowledgement is not received within an allocated time period, the sender, what they will do, they will resend the frame. Both frames and acknowledgement are numbered alternately 0 and 1s. I mean only two sequence numbers 0 and 1, alternate numbers they were used for frames and acknowledgement. The numbering which allows for identification of the frames in case of duplicate transmission of frames. The acknowledgement number defines the number of the next expected frame. I mean the number of frame to be sent next. Okay, the frame 0 received means then ACK, acknowledgement number 1 should be sent, so that the sender can send the frame number 1 on the next time. a damaged or lost frame which can be treated by the same manner by the receiver. If the receiver detects an error in the received frame or receives a frame which is out of order, it simply discards the frame. So it will not send an acknowledgement. The receiver sent only the positive acknowledgement for the frames which are received safely. It is silent in the rest of the cases. I mean, the frames are sometimes damaged or lost. It remains silent. It will not send the acknowledgement frame back to the sender. The sender has a control variable, yes, that holds the number of a most recently sent frame, 0 or 1. So whichever frame which has been sent most recently, that number should be held by the variable yes on the sender side. The receiver side, the receiver has a control variable r that holds the number of the next frame expected by the receiver, either 0 or 1. Okay, so there are the following possibilities of operations. So 4 possible operations we can say here. Either it can be a normal operation, or it can be sometimes the frame is lost, or sometimes the acknowledgement is lost, or sometimes acknowledgement is delayed. So let's see one by one. The first possibility is normal operation. Normal operation in the sense the sender sending the frames. After receiving that frame number, then the receiver has to send the acknowledgement. After receiving the acknowledgement, then the sender has to send the next frame. So here the sender which holds a variable yes equal to 0, that means the sender sending the frame 0, and the receiver side, when the frame 0 is received, then the OR variable is received which holds a value 0, that is most recently received, and the next expected frame should be 1, so ACK1 should be sent to the sender. After receiving ACK1, that is a frame to be expected by the receiver, so the sender sent the frame 1, I mean S equal to 1, so it sends a frame 1, and then when the receiver received the frame 1, then R has to be updated and sends the acknowledgement number 0. That means the next expected frame is 0. So the sender will start sending the frame 0 on the next time. So this will be continued. So this is very normal operation. And in case of lost or damaged frame, suppose any frame has been lost, then what will happen? So here they have clearly mentioned the damaged or lost frame treated by the same manner by the receiver. No acknowledgement will be sent by the receiver. No acknowledgement will be sent by the receiver for the lost frame or the duplicate frame or the corrupted frame. So sender, when S equal to 0, that means frame 0 has been sent to the receiver and R has been updated as 0, and acknowledgement 1 has been sent to the sender by the receiver. That means the next expected frame is 1. So the sender will start sending frame 1, but the frame 1 will not received by the receiver properly. In between, the frame 1 may get lost. So the receiver has not received frame 1, so they didn't send the acknowledgement value to the sender. Okay, acknowledgement value to the sender. And the time period. So the sender has a certain time period after sending a frame. If the time elapsed, then the sender which come to the conclusion that the frame which has been sent recently has not received properly by the receiver. So it starts sending the frame again. So frame 1 starts sent again, resend the frame 1, and the receiver received frame 1, then automatically sends the next expected frame number 0 as sent as an acknowledgement, that is ACK0 to the sender. Then the sender can send the next frame number 0. So similarly, this situation has been handled. Each frame sent, the host must wait for an acknowledgement. So this is one drawback which we can say in the stop and wait ARQ. So we can say that it is inefficient use of bandwidth. So to improve the efficiency, the acknowledgement should be sent after some multiple frames. Instead of sending acknowledgement for each and every frame, it has to wait. So the bandwidth of data transmission which is not efficiently used. So in order to improve the efficiency, the acknowledgement should be sent after multiple number of frames. So the alternative methods for this stop and wait ARQ will be the sliding window protocol usage. So let's see in the next video. Thank you.